All right, let's talk about Sig Figs. Sig Figs are used to indicate the reliability or dependability of a measurement. And generally speaking, that's going to be determined by the tool of measurement. Here we have two tools of measurement. The first one shows centimeter markings. If you were using this tool to make a measurement, you would be able to make a measurement that would look something like this. 2.3 centimeters. Because the centimeters are marked, and you would be guessing at the parts of a centimeter. On this tool, however, let's turn it around. On this tool, there are centimeter markings, but there are also millimeter markings. So the centimeters and the millimeters are defined, and you would guess at a distance in the parts of a millimeter. So a measurement from this tool would look something like 2.3, say 5. There's an extra significant figure in this particular tool because it has higher levels of accuracy. Now, to count the Sig Figs, there are a whole bunch of rules that I gave you, and we'll just highlight the most important ones. First of all non-zero digits are significant. So, in a question like, or in a value like 123.4 grams, there would be 4 Sig Figs. 1 is the first, the 2 is the second, the 3 is the third, and the 4 is the fourth and final Sig Fig. Trailing zeros in a measurement would not be significant. For example, 1200 here. Let's continue this. Grams. That would be 2 Sig Figs. The 1 is the first, the 2 is the second. These 2 zeros trail, or in other words, follow the 2, but are not significant. There is 2 Sig Figs there. All right? Now, you can make those trailing zeros significant by having a decimal place. 1200.0. Let's make that obvious. Now, any decimal anywhere in a measurement will create significance for any zero which already trails. These 3 zeros trail the 2, and there's a decimal place, so they count. That would be 1, 2, 3, 4, 5 significant figures. Another way to make a zero count is to put a bar over it. That bar indicates that this zero is significant, and therefore there are 3 Sig Figs in this one. 1, 2, 3. This zero trails, but it does not have a decimal place in the measurement, and so that zero doesn't count. That would be 3 Sig Figs. Okay? Now, confusion often occurs for zeros that do not trail. The ones that come before the first non-zero digit, such as 0.00123. Again, here we have 3 Sig Figs. The first, the second, the third. These 3 zeros do not trail, and therefore do not count as significant. They're not significant figures. Okay? If you have zeros between significant figures, they would count. The 1 counts for sure, it's a non-zero. The 2 counts for sure, it's a non-zero. And since these 2 are significant, any zeros between them would also be significant. 4 Sig Figs there. Okay. For scientific notation, anything you see in front of the power of 10 is going to count, because proper scientific notation would start with a non-zero, would then have a decimal place, and so all zeros would be trailing, and there's a decimal place. they would all count. The problem with scientific notation is determining uncertainty. Uncertainty, often we assume that uncertainty is the place value of the last significant figure. Well, this is the last significant figure. And you might think that the uncertainty there would be, that would be the tenths, hundredths, thousandths. This would be 1/1000th of a unit, but in fact it's not. Because when we expand this times 10 to the 3, we really have like that, and that 0 is really in the ones place, so it really has an uncertainty of plus or minus 1 for that measurement. Okay, so uncertainty will simply be the place value of the last significant figure. That has 3 sig figs, and an uncertainty of, that's the last significant figure, and an uncertainty of 10. That has 6 sig figs. They all count. The 0 counts because there's a decimal place and it trails a 3. And the last significant figure is this 2, which has a place value of the thousandths. So that would have an uncertainty of plus or minus 0.001. That's not very neat. Let's try it again. 0.001. 0.001. Thousandths. All right?